Okay, so I'm just going to briefly explain how you would do a coding activity linked to the solar system. Now the project, as I've set it up, obviously is driven by a teacher Microbit, so it's quite a big program because it's 6 little programs put together. So I just wanted to talk through how you might model with kids what the individual programs are. So the first program is the light sensor. So we're going to say light level and have some logic. If the light level, I want some logic again. The light level is greater than some threshold, let's say 80. So if it's bright, so if the sun is out, I want to turn the lights off. House lights go off. And let's just make it a bit smaller. Else, if it's dark, then what I want to do is I want to turn the lights on. Okay, let's try that on our simulator. So if it's dark, then so the sun goes in, so you turn the house lights on, and if it's light, so the sun comes out, you turn the house lights off. And that is how simple the program is for the light sensing. Okay, that was the sun. The second part is the moon animation. Now, animations are really simple to do because if you put a block down that shows some pattern and then show another pattern, you usually get a small delay automatically between each one. So the way that you make an animation is just a series of frames. Let's do it something like this. And you can usefully copy frames. This is not quite the same as what I had in the resource, but it's good enough. So let's see if our moon works. Oh, then it goes the other way, doesn't it? So let's got a full moon. And then I think you get something like this. So this is quite good because you're introducing a loop and you're introducing the idea of sequence or program instructions, and you're also introducing the fact that an animation is just a series of images. There's our little moon animation, so that's really, really simple to do. So that was the moon. The next one I did was the shooting star. That's really simple. So what we could probably do here is, instead of having those loops, we could say why don't we say on start, let's have our star no, I think what we'll do is when we press button A, we'll have a star, and when we shake, what we'll do, the star will disappear. So let's try that. There's various ways you can do that one. So when we press button A, we get the star, and when we shake it, the star disappears. Button A, the star comes back, we shake it, the star disappears. So that's quite a simple one to do. And the next one was compass north. That's a little bit more involved, because what you have to do is you have to know what the degrees are of north, south, east and west. There is a standard compass project on the Microbit website that you can do, but basically what you do is you use compass heading. So if the compass heading, let's do a really simple one. This compass heading is less than 90, and usually we have some arrows in here somewhere. There you go. So if it's less than 90, we say north. Else it's less than 180. You probably want this the other way around, but let's just show the concept at the moment, so you can see how you can build up different compass headings. Now run that, you get a compass, and then you can see how when you change the bearings, you get the arrow pointing in a different way. So there's a bit of logical thinking for the kids to do there. There's 4 arrow positions, there's 4 bearings on the compass, so you can talk about between 0 and 360 degrees, which degrees north, east, south and west are, and actually if you're making a compass, you want it so the arrow always points the right way. When you load this on the Microbit, the first thing you have to do is you have to calibrate the compass, and that's described in the instructions. Basically you have to tilt the Microbit around to calibrate it, just like you would calibrating a compass on a phone. And then the compass works, and then you can basically find out which way is north in the classroom. The final one was a magnetic sensor, and that was quite simple to do. There's not a very good simulation for that, but where is it? I think it might be in here. Magnetic force, there you go. So you can find magnetic force strength, so it's in all 3 dimensions. And there's a lovely little block in here called plot bar graph. So plot bar graph and magnetic strength, put a reasonable number in there. And then basically there isn't a way to simulate the magnetic strength on here, unfortunately. But as the magnetic strength goes up, the bar graph changes. Just to show you how the bar graph works, let's use something that we know we can control. Light level goes up to 255. I know I can control that, so you see how the bar graph works. Here's the light level. So as you increase the level, the bar graph goes up, and as you decrease the level, the bar graph goes down. And you might remember that that was how it started off when there was no magnetic field, and then as there was more and more magnetic field because you're near a magnet, then it goes up and down. And that's the coding for the 6 activities. You can see that the code is generally quite simple. It's easily within the range of Key Stage 2 children. In fact, you might get some of the Key Stage 1 children doing some of the simple programs as well. The last thing that we actually did in the workshop was once we told the story, once we asked and answered some questions, once I explained the features of the Microbit that we used, I then handed out a worksheet. And what the worksheet had on it was a series of these grids, and I asked the children to design the images for the sun, the moon, a star, and a shooting star. And I also gave them a number of grids, so I think there's 4 grids side by side like this, and they could design different images. So some might be better than other images, The other thing that some of them did was they designed a series of images. So for a shooting star or for twinkling stars, for example, what some of the children did was they turned on a few little dots, and then they turned on some different dots, slightly different random dots, and they drew these on their grids. And then if you do that as a program, what you then get is you get little twinkling stars. Let's change one there a little bit so they all change. Let's change that one as well, not very random otherwise. There you go. It's quite easy. If you put 4 different frames in there with lots of different dots in, you basically get twinkling stars.